But we would rather do, for the assignment on the bonus section, we would rather do something like this in our main program than something like this, especially if we had more than just first and last names, if we had lots of other parallel items that we had to swap around. Now, even this, just as you're thinking about programming, this is a lot better, but even this you could say, well, okay, what if I had social security numbers? Then I would probably have to do swap pointers, and then I would have another parallel array. Let's call it SSN bracket J, comma SSN bracket J plus 1. And we could go on and on and on like this. Maybe we have like I said, middle names. So instead of last names here, we have middle names and middle names. So if you run into something like this, once again, this should maybe be ringing a bell in your head, like, oh, maybe there's a way to simplify this. I'm doing the same thing over and over and over again with minor changes. I'm swapping two things, swapping two other things, swapping two other things, swapping two other things. Very systematic. Isn't there? Maybe there's a better way to deal with this. Now, if you were doing parallel arrays, this would probably be the best way you could do it. All right, is to have, you could have a swap pointers function so that you didn't have to do these 3 lines over and over and over again, but you still have to do 1 line over and over and over again. And I do want to mention that this that I've shown you here is not quite right, and the hint is, the hint of what's wrong is that C is always pass by value. So what you actually want to do with your parameters here to this swap pointers function is a little bit different than what I'm doing here. But I'm going to leave that for y'all to think about if you want to do that part of the problem. That is a bonus part of the problem, and when I give extra credit, the extra credit can be substantial, so don't think, oh, well, that's like 5 points. No, it's more like maybe out of a 100-point assignment, that might be at least 25 points right there on that bonus. So I don't usually say a specific number of points on these things, but whenever I give extra credit and so forth, the potential bonus points you can get out of it are significant. So I don't know, any questions about the instructions that are up thus far? They're still officially under construction, but that should change by sometime this evening. And it'll be due next Wednesday midnight. Okay? Any questions on that at all? All right, then actually I think today is a good day to start talking about structures. And actually what I was talking about here actually leads into that. So here we're looking at, well, what if we had a whole bunch of parallel arrays to keep track of first, middle, last name, social security number, phone number, grade point average, whatever. Well, that would start to still get cumbersome to manage all of those separate parallel arrays, right? Wouldn't it be nice if we could just have one array of something that kind of encapsulated all the information I wanted to have about a person or about whatever kind of things I was representing? And then I would only have to swap one thing, not a whole bunch of things. So then that would collapse this, for example, that could collapse all these swap pointer lines, and maybe I'd have a dozen or 20 or 30 swap pointer this, swap pointer that, swap pointer the other thing. But why have 20 or 30 lines if I could do all that in just one line? But that means I need some way of grouping information together that goes together. So things like a first name and a last name. or a first name, last name, middle name, or and again, you can add social security number, phone number, street address, city, state, zip code, on and on and on, right? That we could do. So to do something like that, what we need is a thing called a structure. So let's go ahead and start a new program. And put in the usual. And we might want to be able to work with strings. So I'm going to go ahead and throw string.h up there. And we're probably going to need standard lib, since we're going to be doing pointer stuff. And hopefully that's all we need. All right, and for now, this will just be a void main. We won't be doing command line arguments. But so what we want to do here is have a data structure, what's called a structure, which is a way of grouping different pieces of information all together because they all relate to the same thing. So the idea of having something to represent a person, and then you need their name, or the different parts of their name and their address and phone number and so forth, certainly is one possibility. Anything you could imagine creating in a spreadsheet, like if you just have a spreadsheet and you you come up with column headers. So again, we could have name, location, whatever, phone number, whatever you can come up with, lab 1, lab 2, maybe this is a grade book, I don't know. Basically anything you can think of as a column header here. Your rows, each row would basically be something that you think of as a structure, a group of pieces of information that all relate to the same thing. So how can you do that in C programming? Well, in C programming, you do that by defining what's called a structure data type. And I'm just going to straight up show you the syntax for that. I'm going to show you a specific way to do it. And it starts with this keyword called typedef. And I might as well throw in notes and comments here. So typedef is a C keyword for defining your own data types. And then the next part we want to say struct, because the kind of type we're defining is a structure type. So the struct keyword probably better to say for defining and then you open a curly brace, and then inside, and have a closing curly brace, and inside here we define the elements or parts of the structure. And let me go ahead and do a save as here, and let's call this struct example.c. And now the elements or parts of a structure, there's quite a few different terms for those things. These are called, most modern languages, you would actually see these things get called member variables. But older terminology includes fields, And I had one more in mind, and now I suddenly can't remember what it was. Yeah, fields, member variables. I don't know. Those are the two most common. Maybe I'm off base. We might also call them elements. We might call them parts, but those are not very technical. So how do you define the member variables or the fields of your structure? Well, you define it the same way you define normal local variables, but you're defining them as part of the structure. So here we might say car, and let's say first name. And there's different things we could do here. We could make this a fixed array size. Let's say each name can be up to 25 characters, so we always want to go one more than that for the null terminator. And then we'd say car last name, maybe the same limit. Then we might have social security number. So once again, let's say just say SSN for that, and you need 9 digits there. For social security number? That would kind of depend on how you wanted to do it. I think doing it as plain text is probably the best choice. You could do it as int SSN9, but I don't see there's that much point. I'm sorry?
Is there a way to change the data types?
What do you mean change the data type?
The car to end and all that.
Is there, okay. Well, first of all, a car is already an integer, right?
Yeah,
but if you're treating it as, but I think what you really have in mind is a string. Is there a way to change strings to other things? That's a decent question, and first of all, I highly encourage answer these things. Get in the habit of answering these things for yourself. Like you could just Google how to convert string to integer, and
I didn't understand.
well, okay, that's fair enough. Maybe you didn't understand what it was telling you, but if we just look up the string.h library. Actually, yeah. Well, I'm going to do string.h at tutorials point here for this. So let's come in and look at the string.h library. Now, there's a number of things we could do here. I think is that in there? Maybe it's not in string.h. Actually, let me show you a different way to do that, which is actually in standard I/O. Maybe A2I is in here. No, guess not. One way to do it, and probably kind of the most universal way, is to use scanf, this function right here. It works very similar to scanf and fscanf. And what you're talking about as far as converting text to integers and so forth, you're really talking about things that fscanf and scanf already do. Because as a user, when you're typing in, if you're running your program and you type 1, 2, 3, that's text. That's the ASCII character 1, the ASCII character 2, the ASCII character 3. It's not the integer 123 in binary form that the computer wants to work with when it works with integers, right? So, so fscanf and scanf are already things that do that conversion for you. But what if you have a string and it has a number in it, okay? But you want to get the numerical value of that number so you can do addition and subtraction and things like that, and not do things like compare strings and to uppercase and things like that. Well, that's where a function like scanf can come in. So let's go ahead and take a look at that in a little more detail. So if you have scanf, instead of giving it a file pointer, and instead of it reading input that the user types in, you give it the string that contains the text that you want to convert. That's its first parameter. So it's going to look at that string. Then you give it a second string, which works like the format string. Okay? Then you give it the pointers to the variables where you want to store what it scans out of the first string.
What's the second one?
That's the format just like any other scanf. Just to clarify it, let's see if they have an example down here somewhere. Okay, so right here they have a variable DTM and they're just going to copy this string into it. Okay, Saturday, March 25, 1989, right? So DTM is a string, a character array that has this string in it. And then we do this scanf and we feed it DTM, okay? Then we feed it a format, which is just like formats that we're used to working with. So %s, %d, %d, and then we give it where we want to store the things it's going to find. So the first %s, it's going to scan this string, and the first %s is going to match Saturday and be stored in the weekday character array. So they've defined these character arrays up here. And then the second %s will end up matching March, and that will be stored in this array. And then the %d will match 25. Well, that's a text. That's ASCII text 25. That's not really a 25 in binary numbers. It's not a binary number 25. It's ASCII text 25. But this will read that as an integer. Because of the %d here, it'll read it as an integer. And then it's going to store that integer into the integer variable day. And then the next %d will read the next integer here and store that into the integer year. And you could, of course, just do this for, like, if you know you have a string that just contains a number, then you could do this just with 1%d to convert that and then store the number in another variable. Make sense? Yep. All right. So a little bit of a tangent there, but it's not a bad thing to know about. And I think that's probably the best method to keep in mind. There are a few specialized functions. I don't remember where that A2I function, if it's not in the string library, resides. But there are a few specialized functions that just take a string and do one specific conversion, like convert it to integer and so forth. But the scanf is kind of the most universal way of doing those kinds of conversions. And again, it's scanf, so just like we have plain scanf for getting reading and converting input typed by the user, you have fscanf for reading and converting text input from a file, and then you have scanf for reading and converting not really input because it's already in the computer's memory, but reading and converting text data that's already in a string variable. Okay, so over here, getting back to structures, so suppose we have various pieces of information, first name, last name, maybe there's some numeric information we have, like, I don't know, let's just say we have some grades, say grade 1, that needs to be maybe a double, so it can have fractions in it, and then another double, grade 2, and another double, grade 3, and so on. Or maybe you want a whole table of grades, so maybe instead of grade 1, grade 2, grade 3, as soon as you start numbering variable names like this, that should be like a flashing light bulb in your head saying, maybe I should use an array for this. So maybe there's going to be 10 assignments or something, so let's just make an array of 10 things there. But, you know, we might have other things like age. That would probably be an integer, and so forth. So, you know, it just depends on, now, I can't imagine having a grade book where I would be keeping track of people's ages, but this is just an example, so we're just throwing whatever into this structure. So what we've done is we've defined a structure, a set of things that go together where each of the kinds of things in there has its own name. And now to finish this type definition, I actually have to give the structure, the type itself, a name, and that comes after the last curly brace here. So what should we call this? I don't know, we can call it person type or something. I kind of prefer when I define a type in C, actually maybe start it with an uppercase. Usually I start all variable names with lowercase, but if I make a type name, it's kind of nice to, just to distinguish it a little bit, at least capitalize the first letter of the type name, and then use camel caps through it. So we might call this person type. You might feel like adding type there is a little redundant. Maybe we just name it person, okay? But I kind of prefer to add type to a type name just so that it's clear. This is a new data type that I've defined, and it's just a little easier to remember that this is the name of a type, not the name of a variable or something. Once you've defined your type here, then in here, oh, and there's one other thing that we want to do, which is a little bit of a quirk of how these things work, but go ahead and you actually put the type name you want in two places. After, and I forgot about this, but put person type after the keyword struct and before the curly brace, and then again after. And I don't want to get into the reasons for that. If you're creating structures for a C program, do it this way. If you want to dig in and find some of the details, you can find that you can actually define structures without making them part of a type. So you can do this, but then using it means you always have to use the struct keyword. It's just better to define everything as a complete type, and then you can use person type whenever you want to define a variable that is one of these structures. Okay? So, going from here, how do you actually use this structure? Well, in your main program, one of the things you could do is you could declare a variable that is just that structure type. So I could maybe say person type, just like I use int or char or double or any of the other types in the C language. Now I've defined this new type called person type, and then I can have a variable of that type. Maybe I call the variable person. That's one reason why maybe I want to use type in the name of the type, so that later I can actually have a variable that is just person, something like that. Or maybe I just want my variable to be P or something like that. Maybe it's P1 and P2, things like that. So this is defining 3 different variables of that type. And then if I want to access specific fields out of my type, the syntax looks like this. I can do things like person dot, the only one that's really straightforward here is age, so I can say person dot age equals 22, and I can say p1 dot age equals 33. Maybe I can say p2 dot age. I don't know why this would ever be something you would want to do, but we could say p2 dot age equals p1 dot age plus person dot age. So basically you use the variable name of whatever variable is this structure type, and then a dot, and then the field name for the member variable or the field that you want. And so that whole thing works just like a regular variable. And so you can assign things to it like a regular variable, or you can use the value from it like a regular variable.
Dictionary?
Hmm?
Is it like a dictionary?
Is it like a dictionary? So if you're familiar, how many of you have done another computing language that uses quote-unquote dictionaries? It's a little bit like a dictionary. A little bit. In many ways, dictionaries are more flexible, but A dictionary is more like a lookup table, so it's keyword, and then you have something associated with that keyword. This is sort of like that, but there's not really a keyword aspect of this where you could kind of search or index by the keyword. You just have to know what these member variables are and access them directly. But it's not a bad analogy to say it's a little bit like a dictionary if you've seen that in another programming language. All right, well, let's go ahead and just kind of finish out this example so it actually does something. So let's say we wanted to printf these ages at least. Well, actually, let's continue like with the first name and so forth. Let's actually ask the user to give us the names of these people. So something like that, and then we could do a scanf, and then it's a name, so we want to do a %s. We want to have good habits of always limiting the size to the size of what the array can hold, so 1 less than the size of the array there. And well, it's a full name, so let's assume we're looking for the first and last name, so let's do %25s twice to get the first and last name. And then here we would say, let's just use P1 and P2 for this. So P1 dot first name, and then P2 dot last name as where we store it. Oh, whoops, yep. Actually, let's say enter the full name, age, and social number of the first person. We might as well do the whole thing. So first and last name, we want a %d for the age, and then a %9s for the social security number. And actually I should make social security numbers 10 so it has room for the null terminator. And let's see, yeah, that should be good. And let's go ahead and do that for the second person as well. So here we can do P2. And already you see me doing P1, P2, so get your gears, the brain gears turn and think, well, we could have an array of these structures, right? And things like that. So, and that's what we're going to be looking at soon. But for now, just to get the idea of structures, let's go ahead and save and run this in KDebug. Yeah. Oh, whoops. Yep. So we want P1.age. Now here, age is an integer variable, so we actually want a pointer to that thing. So I want to say ampersand in front of it. And again, now this is a situation where you'd have to think about, is this ampersand going to trigger before the dot, or is the dot going to trigger before the ampersand? So am I going to get a pointer to P1 and then try to get .age from that, or am I going to get P1.age and get a pointer directly to that? Off the top of my head, I don't know for sure. I'm just going to put parentheses around that to make sure I get a pointer to the thing I want a pointer to. So we want a pointer to the member variable inside P1, and by putting parentheses around the whole P1.age, I make sure that my ampersand is getting a pointer to that. I'm pretty sure I don't need the parentheses, but why not be explicit about it? And so let's see, what else? We have the social security number, so that's p1.ssn. Now these things are arrays, and arrays are already working like pointers, so again the ampersand is not an issue for the character arrays. But we do need it because that's just a plain integer variable for age. And so need the same thing for p2, so let's do ampersand p2.age and p2.ssn here, and that should do it. All right, I don't think I have any other things going on here, so well, we could print it out, but I'm actually going to run it in KDebug, and I want you guys to run in KDebug with me. So I'm going to keep encouraging you to get used to using KDebug. By the way, just a quick survey: how many of you have used KDebug to help completing any of the labs so far?
Yes, but I don't think I have the right version.
The right version of KDebug?
Maybe an older version.
Email me about that kind of stuff. I can maybe get you fixed up. But looks like about half of you. The rest of you, I encourage you to start doing that. I think you'll find it, unless you found the program so easy that you didn't need it. I mean, that's fine, but I think you will find it helps you as you move forward. Yeah.
We scan, like we put the input that we didn't print it, right? The program?
Yeah, the program's not printing anything right now. We're gonna look at it in KDebug.
You need the dash G down here?
Oh, yep. If we're gonna do this in KDebug, we do. So now let's do KDebug struct example. And set a breakpoint on main. Bring up the output. Well, we don't really need to. It's not going to produce any output, so we don't need to look at the output window. So we're just going to look at the locals, and maybe we'll set up some watches here. So let's go ahead and hit run. So it hits the breakpoint, and we're ready to step through it. So right now, if we expand person, P1, and P2, we see you expand it, and you see all the member variables inside. Notice that grade, again, with character arrays, it shows you those as strings instead of expanding them to individual boxes. That's just the way KDebug displays things. But with an integer array or a double array, numerical array, there you can expand the grade. So within person, within the grade variable, then you have all these boxes of grade. Of course, it's all garbage data in here right now. And then inside P1, you have garbage data, first and last name, social security number. Then you can expand the entire grade array within P1, and it has its individual boxes with garbage data and so forth. So now let's go ahead and do some steps here. So we step, and we're ready to do the first instruction. So person.age is 22, so we should see that change right there. And sure enough, we get a 22 there. P1.age is 33. If we step, we see the 33 go in there. P2.age is P1 age plus person age. So we should be adding the 22 and the 33, and we should see that garbage data should get replaced by a 55. And sure enough, there we have it. There's a 55 in there. Okay. So now we're going to do a, oh, well, I guess we do have a little bit of output. So I am going to need that window. So we did a printf, and then we're going to do a scanf. So we'll step for the scanf. And so now it's looking for a first name, a last name, and a and whatever. Let's say C3PO. And what do we need? An age? How old is C3PO? Anybody know? Have no idea. I think he's got to be at least about 100, right? Nah, probably more like 65. Depends on which movie we're talking about. Anyway, let's see. And what else? We need a social security number. Who knows? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we did that. scanf, and then we see the C in the first name, the 3PO in the second name, serial number 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have age 65. And so let's do another printf, and let's do the scanf, and I don't know, give me a first and last name and an age and a social security number, preferably fictional. Don't give me anybody's real social security number and name. Toss a name out to me.
Jimi Hendrix.
Jimi Hendrix. All right. Good one. Age, if he was still alive.
Dick.
He was born before 1950, I'm sure. He died when I was still a kid, so 85, is that accurate?
It's closer.
It's pretty close, I think. It's in that ballpark. And social security number. Who knows? 987654321. All right, and there we go, and we see that showing up in our P1. Okay, so we can have individual variables that are structures. We can also have arrays of structures. So we can make, instead, and that would probably be more useful. If you're writing a program that was keeping track of information about people for some purpose, you would probably be more likely to want to manage lists of those things. So you'd probably be more likely to want to have an array of person type, not just individual variables of person type. And to do that, I'm going to just go ahead and comment this stuff, just so it's not, so it's still there for reference, but not cluttering things up. So let's just say instead of person type, person P1 and P2, let's say we have person type people, and that's an array of, I don't know, up to 100 people. We might want it to be an array of up to 1,000 or 1,000,000 or whatever. But again, since you already know about dynamic memory allocation, you hopefully are anticipating where this is going, or eventually going to go, where we have dynamically allocated arrays and so forth. But let's just do a plain, ordinary, fixed array. So let's write a program that reads this information. So let's just have a loop to read person data for each person. Okay, so first let's I'll go ahead and make it interactive. So printf how many people, question mark, and then a scanf with a %d, and we'll call this n people, I guess, for number of people. And that's just going to be an integer, so I want an ampersand in front of it. So I need to declare a variable int n people. And that needs to be scanf, not scand. And then, let's see, what do we want to do here? We want to then have a for loop that reads that many people. So we'll do for I equals 0, I less than n people, I plus plus, and then we can do a scanf. And here we pretty much want to do the same kind of scanf that we had here almost. So I'm going to copy from down there. So we're going to get age. Now we might as well throw in a printf that gives instructions here. I mainly throw these extra printfs in part just so that if you go back and look at these examples, it's easier to tell what's going on. Okay, so we want those 4 pieces of information, and then how do we specify where those things get stored? Well, first we start with the people variable, okay, because that's where our list of people is. Then we have to pick out which person we're talking about. So how would you suppose we do that?
Position on it.
Yeah, it's just box whatever the number is, the index. So just like any other array, so people box I is one entire structure, one entire person structure, person type. But now we want to get just the first name out of that. So how do we do that? Dot. Dot is how you get member variables out of structures. So dot first name. Make sure I did it the same way there. Okay. So then same thing for the next one. So people box I dot last name, people box I dot age, and people box I dot social security number, SSN. So that should get us what we want. And once again, for age, we need a pointer to that, we don't want the garbage data that is stored there or anything. We want a pointer to that so scanf knows where to put it. So again, I'm going to just put the ampersand and wrap that whole thing in parentheses. So we have pointer to that peopleboxi.age variable. And again, let's not bother with any output. Let's just save this and run it in Katybug. Did I miss something?
Yeah, declaring I.
Oh, yep. Need an I variable. So if we GCC that thing and Katybug it, let me go ahead. I think people are catching up with me a little bit here, and probably could stand to have a bigger font. I don't know, is everybody actually okay with the font this size? Is anybody struggling to read this? Because it's easier for me if I have more space to work with, so maybe I don't need to make, actually it is size 15, that's not too bad. I think that's fine. It was looking small to me today for some reason. Okay, so we got it built. We run it in Katybug, and we're ready to go. I'm going to reset that breakpoint and hit run, and we're ready to step through it and see what happens. So step, and we printf for the how many people, scanf to read that in. So bring the output window where I can get to it. So let's just do a small number of people, like let's say 4 people, and then let's step for the printf. So we've got the instructions of what we're supposed to enter, and then as we step through the for loop and each scanf, then it's going to be looking for us to enter that information. So give me a name, age, and serial number. Don't make me be the creative one here. Randy what?
Randy Savage.
Randy Savage. Okay, age?
69.
Okay. No comment. And a serial number.
1, 2, 3, 4, 5.
Okay, fine. Next.
Bruce Wayne. Bruce Wayne.
Bruce Wayne. Age.
24.
Serial number or social security number.
423 64 543.
All right, give me another name. Actually, we should be watching what's going on here. So we've already entered 2, and actually I've entered 2, but we haven't done the second scanf yet because I didn't step here. So I've been typing stuff in that's going to catch up to what I've typed in. Let's expand the people array here. And it looks like the data in boxes 1 through 80 is all the same, basically garbage data, but it's all zeros. But if we expand box 0, okay, we see people, box 0, first name, Randy, Savage, etc. Then if we step through the scanf again, it should read the next one that I typed, Bruce Wayne 34, 423, whatever. Again, if we expand people, now if we look at box 1 in people, first name Bruce, last name Wayne, got the social security number there, got the age there, and so forth. And we could just keep stepping through that, but hopefully you get the idea. So we can have an array of structures, and you see how that you access the variables within the boxes within the array, and then the member variables within the boxes. But let's take this a step further now, because we had that grades thing in there. So here I have double grade, all right, and how are we doing on time? Okay. So each person has within it an array of grades. So what if we wanted to actually enter the grades for each person? Let's actually say we don't really want 10 grades. We can just do 4 grades per person. So we'll say enter first name, last name, age, social security number, and 4 grades for each person, just to keep it simple. Now, if we wanted to get all that, the kind of thing we might type in would be, you know, Joe Jones, age 19, social security number 333-333-3333, and then we'd have to put in the grades: 88.6, 99.9, 22.2. Joe started slacking off, 11.0, whatever. Okay, so we would want to be able to read this, but we probably want to read the grades themselves in a loop to get them into the array. So normally I might say try and figure out, well, actually we've got 8 minutes left. Take a couple minutes and try to write a loop that will read in 4 grades into the array. Notice that we do this by having this loop entirely inside. So we have the outer loop. Each time through loop does 1 person. Inside loop, each time through that loop takes care of 1 grade. So we want to see if we can read the grades into the array for the correct person. Anybody have a suggestion?
For A equals 0,
A?
yeah, make sure it's
Okay.
A less than 10.
Okay, well, we're only doing 4 grades, so.
Okay, 4. And A plus
Okay.
scanner. Pushing LS. That's for the double, right?
LF. That's what you want. So to read a double, you want percent %LF.
Yeah. And then, so people I dot grade A. Pointed to that.
So people box I dot
Slash A. Grade bracket A.
grade box A. Yeah. One thing missing here.
Pointer.
Yeah, we want a pointer to that. So again, just to be sure that we're getting a pointer to the right thing, I'll put parentheses around the whole thing, then an ampersand in front of that. So we want a pointer to whatever this is,
And declare A.
and we need to have A declared up here at the top, correct? And let's see. So let's break this down just to make sure it's clear. So we want to read in the grades for whichever person we're reading in right now. So the index for that person in our array of people is I. So we want people box I to get the correct person structure. Okay. Once we have that structure, we have a dot to pick out what variable inside that structure we want. Grade is, actually isn't it grades? Did I call it grade or grades? I called it grade. Probably should call it grades, plural, just makes more sense since it's a set of grades or a group of grades and not just one grade. And then we have to pick out what box in that list of grades we want, and so that's what our variable A is going to do, is going to be the index to the box within grades that we want. And so we're getting people box I dot grades box A, and then we want a pointer to that to tell scanf where to actually store the data that it reads. So if we throw a semicolon at the end there, that should be it, and we should have just enough time to try this in Katybug and watch it in action. So let's go rebuild. Whoops. Oh, I had some example text down there that is not part of the program. All right. All right, so with Katybug running, I'm going to reset this breakpoint, hit run, step. Doesn't really matter how many people because we're not going to get that far, but I'll just say 3 people. Come back over here, step. So we are in the for loop, we're on the scanf, step. So let's enter a name, Joe, Jones, age 22, and social security number 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's all in there. And that takes care of the first scanf. Now we're on the inside for loop, so let's step, and now we're on this scanf. It's going to look for 1 grade, so step, but I'm going to type all the grades at once, so 88.8. 99.9, 111.11, and 222.22. Great grades, right? So now the scanf is only going to, well, actually we haven't even hit the scanf yet, I think. I'm not sure if I stepped over or not. But let's actually look at our people array, box 0. So we see we got Joe, Joan in there, SS social security number, and age are in there. But now we look at the grades. Okay, yeah, I did do the first scanf. So now we step, we're about to do the next scanf, and since I've pre-typed the input, it's just going to keep reading what I have there. So step, and so it got the 99.9 in the next box. Step, comes back around, got the 111.11, back around, got the 222.22. That should end that loop, and now we're ready to go around to the next person. So, I don't know, Sally Shells, age 21, 987654321, and if we keep stepping, we can start entering grades, 333.33, 444.44, and so forth. I'll just do those two for now. Yeah, wait, I have to hit return or it won't read them. So now if we look at box 1 of people, we see Sally Shells, 9876, age 21, grades, and then we have the 333. If we step a couple more times, you've got the 444. And so forth. So hopefully you're starting to get an idea how structures work, and they can have arrays of structures, and inside those structures you can have arrays. And so next week, instead of just a plain array of structures, we will have an array of pointers to structures.
Do you pass, when you're passing a structure to a function, do you do it the same way as if you were passing like an integer or a char or something? Just like person type and then the name?
I would have to double check, but I don't think you can pass structures by value. You'd end up getting something strange happening. Might have to double check. But any realistic scenario, you would actually just want to pass pointers to the structures. Yeah, and even what I've shown you here with an array of structures, you probably don't want to do that because, well, just think about sorting, right? For example, if you had to swap two structures, then you're stuck with the, okay, first you have to swap the first name and the last name, then you have to swap the last names, then you have to swap the age, then you have to swap the, so, but if you had pointers to the structures, then you just change the pointers. And so, working with pointers to structures. So the next thing we'll do is an array of pointers to structures, and then we'll move on to these things called linked lists, and there's no array at all. And each thing just points to the next thing. And that gets interesting.
Have a nice weekend.
See you next week.